Hello guys! Now you already know that OSPF can find the OSPF neighbor, can exchange some message and then get the routing information, and how to give the configuration on the devices. Then the devices can send out the OSPF package. If you want to know it, let's do now and to see the detail of the video. Thank you.
This video we will talk something about the basic OSPF lab guide. And this is a dynamic routing protocol, right? And if we run this protocol in our network, all the routers can get the routing information from the OSPF neighbor. Of course, how to exchange the message to find the neighbor, how to exchange the link state information, that's because we add the OSPF command on the devices. So in this scenario, we will do one practice and then to test the result, what means OSPF and how to do the configuration. And first, we also see the background. If now a branch of an internet company plans to construct a new network, and according to the plan, we will use Ethernet and we will have 3 routers, router 1, 2, and 3. And about router 1, 2, and 3 is a backbone area, and the area number will become 0. And the network between the route 2 and route 4 is area 1, and between PC1 and route 1 is area 2, and between PC2 and route 3 is area 3. So, like the topology I show with you, I use different color to indicate different area, right? So totally we will have 4 areas, and area 0 is backbone area. And we will use route 1, route 2, and route 3, the 3 interface, and belong to the area 1. And then this 3 router also will connect with non-backbone area. And then if you want to, all the PC want to communicate with each other, all the router need to know the routing information of our whole network. So that's why we want to use a dynamic routing protocol. Of course, in the real network, if you choose a static routing, it also can work, but you have to do multiple commands. So about the lab purpose, the first one, we have to understand the principle of the open shortest path first protocol, OSPF. And the second one, we have to master the basic implement and deployment of the protocol. And here is the topology. And about the simulator, I also add the basic parameters on the empty area. What's the IP address of this PC and also the network IP address between these routers. And this is the IP segment. And about the 4 routers, route 1, 2, 3, and 4, all of them will create the loopback address. And we will use this loopback address to become the route ID, something like this. And also the next part is about the OSPF area planning, the backbone area and the non-backbone area. And we will give special parameters to change the DR of route 2. So they are main parameters. And the whole requirement, let's say the practice guide. The first one, we have to create the loopback address of each router and then to select this loopback address, router IP address, the loopback address to become the router ID of each router. And the format is XXXX. For example, if we use a route 1, and the route ID should be 101.101. And the connection IP address of the PC1 and the route 1, this segment I already explained on the empty area, right? And also the IP segment of PC2 and route 3, and another one for the IP address segment from route 1, route 2, and route 3. These 3 physical interfaces will belong to the same area. Okay, and another one for the OSPF, we have to deploy according to the topology and meet the requirement. And we have to ensure that the route 2 has the highest priority and can be selected to become DR in the IP segment of route 1, route 2, and 3. Because as we know, the DR selection belongs to the physical interface, not about one router. That means if you have multiple interfaces belong to different area, different link, maybe we will have different rules. And finally, we have to show IP OSPF neighbor to check the status of OSPF. And also you can check the result of the IP routing table. So this is the requirement. And the second one, if we want to finish the command, the first we have to add the basic configuration, includes the IP address, right? And if you have the switch in your network, if this switch is a layer 3 switch, maybe you also have to create a VPN and to create some SVI interface. But in this topology, the switch SW1 only is a switch to connect with 3 routers. We don't need to do any configuration of the switch 1. And the second one, we have to add the basic OSPF configuration and also change the interface priority to let the interface of route 2 to become the DR. So these are key points we have to do. And now let's finish the first part. The basic configuration includes the IP address. Because about the router, we have physical interface, and you also have to create a logical interface, loopback interface, and to make an IP address and select to become router. So here, about route 1, I already opened it, right? And this is the first time we log in, so you have to create, enable, enter, and to give a password. If you already do the practice one by one about the RCNA course, maybe I think it's very familiar about you. And now you can directly to change the name, enter the global configuration command, and then to change the host name to become R1. It's better if you use different host name to distinguish different devices. Maybe if you don't do this process, maybe you will give the wrong configuration in wrong devices. So it's better for you to change the host name. And in the real project, maybe every host name has special meaning. Okay, but here I only use different number to distinguish different routers. So this is a route 1. And first we have to create one loopback address. Loopback 0, loopback 1, yes. Okay, now enter the interface and give the IP address. IP address 1.1.1.1.32. Because this is a logical interface, that's why you can directly to give the subnet mask to become 32. And enter exist and enter the physical interface. About route 1, we have 2 physical interfaces. One connect with the PC1, right? And about the PC1, you have to enter the physical interface and no switch, and then give the IP address to become 10.1.1.254 and 24. And later exist, you have to enter the gigabit 0 to 0 and also no switch, and then give the IP address to become 192.168.1.1.24. About the IP address planning, the detailed requirements we already described on the lab guide. So you only can write to become a table and configure one by one. So this is a basic IP address of the route 1, right? And then about route 2, you also have to add the basic one. If you are very familiar about all the commands, maybe you can directly to configure everything. For example, about route 1, after basic IP address, then you can directly add the OSPF configuration. But if this is the first time for you, maybe it's better to suggest to follow the OSPF lab guide and do step by step to finish the basic one and then to do the dynamic routing protocol. It's better for you to do the troubleshooting. The password is 123 dot and 123 dot. Oh, that's why I gave the wrong password. Okay, and the config T changes the host name to become R2. And about the R2, you also have to create the loopback address. Loopback 0 or loopback 1, it don't matter. Okay, it don't matter. This only is the ID and will be done by local. We will don't change the information to my neighbor. And then give the IP address to become 2.2.2.2.32. Okay, and enter one physical interface to connect with the switch and no switch, and then to gives the IP address 192.168.1.2.24. This is the IP address to connect with switch. And another physical interface, gigabit 01, in the no switch. This IP address segment is 192.168.2.2, 2.2 segment. Okay, so this is a basic one. So if you don't maybe worry that maybe gives the wrong parameters of IP address, if you worry about this one, you can do the test now, because about our route 1, the physical interface already get an IP address, right? So about route 2, you can enter and to do the ping test on the user domain ping 192.168.1.1. You can direct ping. That means the IP address of route 1 and the IP address of route 2 is correctly. Okay, so this is a basic IP address of route 2. And later is route 3. Web config and enable, and the password is Ruijie123, Ruijie123, and config T to change the host name to become R3, and create one loopback address, and give IP address to become 3.3.3.32, and enter the physical interface of 00, no switch, and the IP address is should be 192.168.1.3.24. So when you do the practice, especially for IP address, because you have multiple physical interface, so you have to give the correct IP address in the correct interface. And then enter gigabit 01, the segment, no switch, and the IP address is 10.1.2.354.24. Okay, so if you want to do test, you also can ping route 1 physical interface and route 2. You cannot ping PC now because the PC we don't give IP address. Ping 192.168.1.1 is correct. You also can ping 1.2, also is correct. That's why we say when you do the configuration, you can test one by one. And later is route 4. Enable and give the password, and also the password what's the name to become R4. Enter loopback 0 and give the IP address 40404032. Enter the gigabit 00, no switch, IP address 192.168.2.4.24. Okay, so now we already finished the IP address of the routers. You also have to add the IP address of the PC. About the PC1, IP 10.1.1.1, and the mask is 255.255.255.0. Gateway is 10.1.1.254. So it's ready. Now you can ping your gateway. 10.1.1.254. It's pinged successfully, right? And also about the PC2, IP 10.1.2.1, 255.255.255.0, 10.1.2.2.54. Enter. Also, you can do some tests for your gateway. If you have some wrong configuration of your gateway or maybe physical IP address, you can directly troubleshoot at the first step. Otherwise, it's more difficult for you if you add the other configuration. Now, all the physical IP address should be right. Then we have to add the basic configuration of the OSPF. So one by one for the router. About the OSPF, it's no need to add the command on the terminals. So about route 1, come back to route 1. you have to enable the OSPF protocol at first. So the command is router and then OSPF. And you can use a question mark. You will find that we have to provide the process ID, right? And this is the ID range. And this ID only used for local. That means if route 1 and route 2 have different OSPF process ID, it don't matter. When we check the parameters, we don't check this information. And why we need the multiple process ID? Because maybe in some scenario, route 1, route 2 is better. Route 2 will use process ID 1 to do the communication with route 1 and route 3. But maybe we will use different process ID to connect with route 4. So in this scenario, route 2 only use OSPF protocol, but actually we will have two routing table, and they will not directly to send the link aggregation information to the neighbor. That means if I receive the routing information from route 4, I will not forward the message to route 1 and route 3. So you can do some control. This is a higher advanced feature. Maybe in the future we have the course of RCNP. We will explain the detail. Okay. Now we use the process ID is 100. Of course, you can use the other process ID like 1, 2, or 3. If you don't choose the process ID directly enter, that means we will use the default process ID 1. And then to give the router ID. If you add the command router ID, that means we manually define who is our router ID. Okay, so we only have to choose yes. If you don't define the router ID, the router will select by the interface because we already created 3 interfaces on route 1, right? And then you have to network the segment 1.1.1.1, and we will use sub wildcast to indicate the interface. And the area is area 0. It's done. And also network the other interface. And what's the meaning of network and why we use the wildcast mask 0 to 0 to 0? And about this part, we already explained on the principal video, right? So if you forget, maybe you can come back to check the detail. And also networks the physical interface connect with switch 192.160.1.0. By the basic, if you use the IP address and the wildcard, and this range can include the physical interface or logical interface, it's okay. You can use the other any wildcard mask. It doesn't matter. Area 0. Okay, it's done. So now 3-part interface will already enable the OSPF. So if you have the Wireshark tool now, you can get some packets. On the link, maybe you already can see the hello packets of the OSPF. And another command here is a passive interface. Passive interface you will find is the interface to connect with the terminal. What means a passive interface? About the network command, if you enable the interface of the OSPF, we have 2 functions. The first one, about this physical interface, we will receive or send out the OSPF message. The second one, I also will add this interface information into the LSU or maybe LSR in this message and send to my neighbor. So there are 2 functions of the OSPF if you enable the interface. But about the special interface to connect with the terminal, like the gigabit 01 to connect with PC1. This physical interface, like the IP address, the mask, I only need add this information and then send to switch send to route 2 and route 3. So route 2 and route 3 will receive the segment of the PC1, right? But we don't need to send out the message to PC1. So in this scenario, you can change the interface state to become passive interface. Okay, so this is a basic configuration of route 1. So now if you do the configuration for route 2, it should be better to understand. Ruijie 1, 2, 3. Okay. T. Also create router OSPF 100. And then the router ID should be 2.2.2.2. Yes. And later you also have to network 2.2.2.2. About the network physical interface, you have to add the correct area. Otherwise, maybe you cannot establish the relationship with the correct neighbor. Because the network ID is one parameter, we have to do the negotiation. If the same link we give the different area ID, they cannot establish the neighbor. So pay attention about this one. So this is the configuration of the route 3. When we add the command to enable the neighbor with route 4, you will receive the OSPF warning, right? The status is changed because we already received the hello packets from route 1. Okay, so this is route 2. And also the same about route 3. OSPF, sorry. Router OSPF 100, and then router ID. Yes. Then network 3.3.3 0.0.0 0.0 network 192.168.1.3 0.0.0 0.0. Then another interface 192.168.1. Oh, what about this one? Should be 10.1.2.254.0.0.0.3. Okay, and also you have to center the interface, passive interface to become gigabit 01. The same reason of route 1. So this is a full configuration of route 3. And another one for the route 4. Enable Ruijie 1, 2, 3. Config T in the router OSPF 100. Router ID 4. Yes. And then network 4. 1. Network 192.168.2.4. Okay. So now we already finished, right? So this is the basic configuration of the OSPF. It's very easy for us. And another one, we also have the special requirement. We hope that the route 2 can be a DR on this link, on this segment. So how to change one router to become DR? You have to change the priority. But now we already established the relationship of OSPF neighbor. So who will become the DR on this link? You can already use the command to check now. Exist. Show IP OSPF neighbor. This is route 4. You can check on route 2. Because about route 4, we only have one neighbor. Show IP OSPF. Oh, not about this one. We only want to check the neighbor information. Neighbor. Because here you can check the status of the DR and BDR. And now you will find who will become the DR. On the physical link 0/0, route 1 will become the DR, right? According to the principle, because route 1 is the first time to send out the OSPF message, and according to the principle, we will select route 1 to become DR. And Now, if you want to change the DR status, first you have to change the priority. And how to change the priority? For the route 2, you have to enter the physical interface. And then you have to change the IP OSPF. And the priority will become 255. So if you change now, according to the priority, route to physical interface /0/0 will become DR, right? And if the other link you also want to let the physical interface to become DR, you also have to enter the physical interface 1 in the IP OSPF priority to become 255. But if you change the priority now, you also can show IP OSPF neighbor. You will find the 1.1.1 still will become DR, right? That's because according to the stability, if the link already select who is DR, we have to restore the devices, or maybe the network is broken, we will select a new DR or BDR again. So in this scenario, maybe you can try restart the OSPF. For example, about route 1, enter the physical interface 00 and shut down it, right? And then you will find the status is changed, and also the OSPF status will be changed, and no shutdown again. So in this scenario, come back to route 2, then you can check the status again. Now 1.1.1 will become DR other on this link, right? And who will become a new DR? You can check the route 3 on the other status. Show IP OSPF neighbor. Okay, 1.1.1 is DR other, and now the 2.2.2 priority is 255, and the status will become DR. So that means our priority is successful. So later is the status to check IP OSPF neighbor. We would find the neighbor already changed and the priority to become 255. And then you can check the IP routing table on each router, and you will find all the routing information that we can get on the router. IP route here. If you use the show IP routing, you will find all the routing information, includes the direct routes and the routing from OSPF. If you only want to check the OSPF protocol, maybe you can add the OSPF. Now about the route 1, we have 5 segments, right? If the character, the code only is O, that means I receive these 2 segments from the same area, from area 0. But the other 3 segments from the other area, one from area 1, this is route 1, one from area 1, another from area 3, right? So this is the basic one. And about the route 2, you also can check show IP routing. You can see all the information here. So now you can use the command to check one by one. And then we can test the result between PC1 and PC2. So about the PC1, now you can try to ping. PC2 is 10.1.2.1. We can ping successfully, right? And also same about PC2, you can ping 10.1.1.1. You also can ping successful. So the network connection is ready. And of course, about PC2, you can ping the loopback address of route 4. Now it's ready. Okay, so this is a basic configuration. And about this practice, the key point, if you want to change the status to become DR, you have to change the OSPF priority in the physical interface. And if the status is ready about all the physical interface, you have to restart the devices, then you can find the correct result. Otherwise, we have to wait the DR is broken and then to select the BDR to become new DR. And in the rest DR other, we can select one to become BDR. So this is a principle. And the second point about the interface connect with the terminal. This interface, we no need to send out the OSPF message, right? Because about the terminal, we don't want, when I receive the OSPF message, I will directly discard. So this is the waste, the resources waste of the physical link, and also the resources waste of the terminal. So in this scenario, you can change the interface to become passive interface. So that's all about the OSPF practice. I hope you also can do the test according to the lab guide, and then you can have some summary on your real network. Thank you.